think she uses the floor as a springboard. Hi, I'm Steve from 123D. Today we shall be doing an unboxing and build video for the Death Racer. The kit was provided by BigTreeTech. So for those who are not aware what Death Racers are, the real Sam Prentice came up with this idea a while ago, and most of the events that 3D printers and exhibitors attend, they have Death Racer races. We saw these for the first time when we exhibited at Smurf. We got to chat with Sam, and I've spoken to Sam a few times since then, who was kind enough to provide me the latest revision build plans, and we have the BigTreeTech kit. So first things first, I shall unbox said contents of the kit. Now you can buy this kit with pretty much everything you need apart from the LiPo batteries and a charger. So I will unbox and lay all the components out in front of me, briefly tell you what they are as and when I do. 3 carbon fibre rods. We have lots of packages of screws and gears. We have 2 flanges. We have some heat inserts, more screws, a load of pins. So we've got 60 pins. Now these are for actually attaching or joining the caterpillar tracks, which is handy. They're all cut to length, so you don't need to mess around with all of that anymore. Some more screws, 2 MG90S servos. We have our speed controller, a little piece of pre-tinned wire, also a Servo custom splitter cable. We also have a 25 kg heavy duty servo, a CNC aluminium servo, some more bits and fittings, some bearings, the infamous kill switch, some Wago connectors, a fan, a motor, a bigger motor, and another motor, and infamous rubber duck. And then under the foam, we also have a transmitter. So I shall put that to one side, lay that down because we shan't be needing that immediately. Also, we have already gone ahead and printed all of the parts out for the kit. Last time that I spoke to Sam Prentice, they were on about putting them on printables for you to buy. It's not a huge amount, or if you want to, you can actually subscribe to Michael Badley's Patreon, where you have to pay £1 and you can download the latest revision of all the files from there. So I have already opened up the PDF instruction manual. I will explain what each of these bits are as and when I come to assemble. Probably should give you a little bit of a heads up on what we have tool wise as well. I've got a basic toolkit. I have myself a set of long nose pliers. I also have Modify 3D Pro tool. This is for inserting heat inserts, and I've got a knife. I don't know if I'll need a knife, but I have one just in case. So for the first part, it's asking me for the mainframe assembly. So I should delve into my box. And we have this, which is part of our main frame. We also have this, which is the battery tray. We have this, which is the mainframe cover. These are all printed in our own brand PLA. So we followed the instructions. We printed them with the specified amount of infill and wall count. So links to all of these products, by the way, will be in the description. There is a variety of different parts that we've printed in some of different materials because they are more hardware than others. But this mainframe is printed in our PLA, our own brand, yellow, as you can see, and it prints divinely. With that being said, it asks me for heat inserts. So we want some of these first. It also says, do we have any CA glue? Do we have super glue? We shall see how the Gorilla Glue holds up. On the PDF, 1, 2, 3, I'd imagine it's all of the top holes, put the cover on. So I shall turn the temperature down, because last time I used this, I used it for ABS. So it's a bit hot for PLA. Probably 300 degrees will be plenty enough. You have 1 or 2 ways of doing this. You can pop the heat insert into the hole to start off with, and then when you're inserting it, make sure that it's square. Just let it sink down, and you want it so it's just below the surface. And on the heat insert, there's a little collar, so that's the part that actually goes down into the hole first, not the serrated edge. The serrated edge is the part that you want on the top side, because that basically is what stops the heat insert from spinning once you've got it in and tightened your screws up, which you don't need to over tighten, otherwise you'll strip out all the hard work that you've just done. So as you can see, there's nothing really hard about doing this, and it's also telling us we have 1 hole here. Superb. scroll down and come to the next chapter. So on here, it says that sits in there. This is why we need CA glue. So inside this printed part, we've got a little channel recess, and then this quite simply sits into the recess, located beautifully. So I will get some glue and just put a very, very thin bead in that channel, and then I will pop that in there like so. Now, saying this is optional, can be fitted to the front of the main frame, and we position that as shown in the pictures. In the pictures, it's showing the wires at the back. Hold off installing the frame cover for now. We've got plenty of work left before that can be installed. An optional cooling fan can be fitted in front of the main frame. Basically, what it's telling us is we don't need to do that in a minute. I will scroll down to the drive frame, so I'll pop all those out of the way. This is where we have more heating inserts. We have 2 of these, which are mirrored parts opposing. It says the instructions will depict the left side drive assembly, but it would be efficient to build both at the same time because we love efficiency. That is what we are going to do. So what we have noticed in the BigTreeTech currently is that there isn't enough heat inserts to actually do all of the jobs that it's asking us to do. So I've had to just grab some more out of stock. And again, we will leave a link to these in the description. My magical tool, and I will proceed to insert all of these into the holes that is marked on the PDF. This is also PLA. Any structural parts, i.e. chassis frames, we printed in PLA, and then any mechanical parts, i.e. gears and alike, are printed in PETG, as it just gives you that little bit better wear resistance and strength. But you can print them out of whatever you want, really. For durability, we decided with PETG. All I'm going to do is use the first one as my instructions for what hole patterns to follow for the repeat process. Now, if these don't go quite in perfectly square, it's not the end of the world. You can like heat it up and just lever it across so it is true. Superb. So once you're done, that is what you should have. Now we do have some more to do, but I haven't yet figured out. I've got 2 lots of these parts. I've got a deeper one and a smaller one. So I'm just going to skip ahead and I will put the little pinion on the motor. May not be an easy task. It definitely won't be. It went on a bit. I think that's it. They are very, very snug. I'll do the other one. I think as long as you don't go absolutely ridiculous and give it a real... The last thing, you don't want to push the shaft out the back end of the motor. So they're both on and appear to be flush with the end of the shaft as shown in the picture. So then it wants these. So I was incorrect. This is not a motor. This is a gearbox. So these are the motors. This is the gearbox. This is a printed spacer. So the spacer for the motor and gearbox is printed in PETG. To assemble the motor, start by installing the supplied 11-tooth gear onto the input shaft of the motor, which we have just done. Make sure the gear is squarely aligned and flat to avoid damage to the gear when applying force, which we tapped it on the end so we haven't interfered with the teeth. The gear will be very tight. Tap it down or squeeze it with a press until the end of the gear is flush with the tip of the shaft, which it is. Next, unscrew the 4 M3 bolts holding the planetary gearbox together. Okay, so what it's asking us to do is take those bolts out of there. For that, we shall need an Allen key. I think why we're doing this because we're going to replace these screws with longer screws that go straight through. Carefully, that's the output shaft. So it's basically asking me to carefully remove that there off. So inside there, you've got some gears. Now it says, fit the motor spacer between the 540 motor and the gearbox base. Motor spacer. And it says the gearbox base. So does it want me to put that on there? I think it does. So it wants 2 M3 8 screws. So spacer, line that up with the holes on the motor. Then grab that part, line the countersunk holes up, it's saying, with the other holes, and then secure it with those. Categorically, those screws are not long enough. So I've got M310, which might be long enough, because the M38 literally only just poked through, which will be no good to nobody. May look more promising. Right, So that appears to now be correct. The instructions say to use through the countersunk, 2 countersunk holes into this plate with your spacer between into the motor. It says to use the M3 8mm button head bolts. Now in the BigTreeTech kit we do not have any M3 button head bolts in an 8mm. We only have countersunk bolts. Those are not long enough to go through the base, through the spacer into the motor. So I've had to use the M3 10mm countersunk bolts. They have worked perfectly, and then I've just checked they're not interfering with the motor in any way, because you do not want those to go through and hit the windings. So they appear to be okay. So with that little conundrum figured out, it now tells me to combine the motor gearbox, gently meshing all the gearbox together and retightening with the 4 M3 bolts into the mount. So basically the 4 bolts that we took out need to refit. Firstly, make sure the gears are meshed in their correct manner, and then grab the screws that we removed before, pop all of those back into the holes we removed them from. Make sure they're all lined up. Again, opposing directions, and just get them all to a point where they are, and then double back, just nip them up. And then you should have that. So I'm going to quickly repeat this now on the other one, so they're both at the same point, which now I know I'm doing. Shouldn't take very long.
12 seconds later.
Okay, so now have 2 motors both assembled exactly the same, and it wants us now to attach the motor mount to the assembled motor with 4 M320 countersunk bolts. So what I need to do is really try and figure out, before I go any further, which one is going to be the one that we want. So I'm going to do that by a little bit of guesswork. Right, so we have now figured that part of the conundrum out. So in the print files, guys, you've got a small and a large. We want the large, so I'll pop those aside. And we need more heat inserts. More heat inserts! 2 on both sides of these, basically. So 2 top, 2 bottom. And then from what I can see, when you've secured the motor and gearbox assembly to this part that I'm inserting these into, we can then screw it through and hold the whole thing in place with another 4 screws. What did you do at work today, dear? Well, today I built a tank with a big swinging bludgeon. Right, so we have inserted all the inserts into these. We want some flanges. Here's our 2 flanges, and they go with these pinion gears that were printed. Again, these were printed in PETG. I think we printed them 100% infill, so they are solid. In this bag we have some very, very small grub screws, which I am not going to get out of the bag just yet. They can stay exactly where they are. Now he's asking us to attach the motors to the mounts with some M3 20mm screws. So let me find them, which are here. So I'll do that first. So we're going to want 8 of those. We have got 4 blank holes left over. You could actually probably ream these holes out if you wanted to with a drill bit first. You'd have to be very, very precise. We just best off threading the screws in through the plastic and then into the actual metal. That way you know everything is snuggety-dug. Let the power commence. Lovely. Yeah, if you've got one of these, use it. Bingo. You just check that everything still turns. And obviously there'll be quite a bit of resistance now because you've put a gearbox on. Next up, these little pulleys, pinion gears. Again, I've got these, and it doesn't give me any indication in the instructions as to what I am actually fixing them together with. Now, it doesn't tell me what screws to use for these. Now, I am going to make a judgment call and surmise that they are these little 10mm self-tapping screws. We will find out. So I have 19 of these. I think I was correct. In my own personal opinion, I wouldn't put a machine thread screw into a printed part. I would rather use a screw that's got a bit of thread and bite, which made me guess these ones. Now, as you notice, I'm not putting these in with the driver because it's a screw into plastic holding a metal part in place, so I don't want to go mad and really crank them down and over tighten them and strip the threads out, and then I need to reprint this critical part which provides transmission, i.e. drive, to another gear. As you can see, my 2 PETG pinion gears are now both fitted with the flanges, and I have some grub screws. Oh, they give us a spare one in case I lose one. Do you have any thread lock in here? Because you don't want these little bad boys coming loose. So a little bit of thread lock. There we go. We don't need a lot. We only need a little smidgen. Get my grub screw. Coat it with some thread lock. Get my pinion gear. Pop it in a hole on the flange. Make sure it's aligned with the flat on the shaft. So I'm not going to nip them right the way up, because it says here we may need to adjust them later. And again, top tip, guys, little tiny grub screws, impossible to feed in with your fingers. So put them on your Allen key first, making sure that my flange is aligned correctly with the flat on my shaft. Pop in the screw and repeat on the other side. Oh yeah, we got spinning dooblies. Right, that one, that way. Get in there. The flange needs slackening off. One thing I will say, our own brand PLA prints very, very well in terms of tolerance. Right, 4 312 countersunk bolts to secure the motor mount to the motor frame. So, motor mount, motor frame, M312. I don't think it's a biggie, but no, I haven't really got many of those left. So, on this instruction again, folks, it does say that we should use a 12mm M312mm. We don't have a 12 M312mm countersunk screw in the pack. However, the M314 countersunks fit perfectly to the point they are literally finished flush with the inside of the mount, which I would call perfection. So 2 in the top, 2 in the bottom, and rinse and repeat with the other one. Don't go crazy with these. If you wanted to, you could always put a little bit of thread lock on them if you're worried about them coming out. So that's that one. I'll do the same again with this one. So I'm gonna now fit the bearings to the carriages. This is an acclaimed simple case of pushing said bearings into the recesses. It does help if you get them pretty square as you try and pop them into place. There should be a snug fit, which in this case ours are beautiful. So I've repeated that with both parts. So 8 bearings that were supplied are now all fitted. So I have my part, I have the wheel assembly, which I will slide through there. I have another blank one, which is the rear. Just move these cables out of the way. What we're looking for now is that the pinion gear that we fitted meshes nicely, which it does. So now, before we proceed any further, those little grub screws that we fitted before, we now just want to snug them into place. We should be free to move with no binding. I'll put more thread lock on that one because that one wasn't all the way in. Okay, it's lovely. So repeat that again with the other one, and again that meshes nicely. Super. It wants us to now slide the 2 20mm rods through the main frame. These will interface the grooves on the motor frames to strengthen the death racer. So you can't beat a little bit of carbon fibre to strengthen. They're very well wrapped. Oh dear me, come on. There we go. So through the frame, hole pushes through. So grab the other one, same again, like that. Feed the motor wires through the main frame. Right, so I'm looking at now, I'm assuming that's the front because those holes there are where we can fix the fan. Feed those. What's going on? What's going on here? That's what's going on here. I have it upside down. The 2 holes for the skirts are at the bottom. That's how we want them to go. They do need zippy tying into place. Take those wires, fish those through there, like that. I'll attach the motor frame assembly with 6 M312 countersunk. Now this is the problem that we had because we didn't have any M312s. I have M310 countersunks. So yeah, the M310s are just long enough, which is a good job. So where we're up to, we've now secured both of the motor assemblies to the actual mainframe. 6 holes in each. Carbon tubes running through, which are supported on there, basically to give it all a bit of rigidity and strength. So that is currently where we're at. We could probably now, I'm not going to fit those yet because we'll probably need to get inside here and I do need to do some zippy time magic, but we'll get that sorted out very, very shortly. Pop that to one side. Now, we need a lot of parts. 32. So, here in the box, we have lots and lots and lots and lots of TPU printed tracks. So we need 32 of these per side, and basically they lock together, and then with these pins we will push the pins through. Save your fingers, get a pair of pliers and use the metal. Just make sure you line everything up as you push like that. So I shan't bore you with this part. You continue that with 32 for each side. Be back shortly.
A few minutes later.
So we have fitted one track, and we found the easiest way is to basically start it off bending said tracks together whilst feeding the pin through. Just found this to be easier than trying to actually line up. Here we go, and then finish off by pushing it home. And we have tracks. I don't think we need this part for the moment. It's telling us now front body, the nose, and whatnot. The nose frame, we want the grille. Here's our grille. Servo frame, which is this part. Driver console, which I assume is that part. These little servo arms. This frame. Headlights. So first off in the image it's saying 2 heat inserts in these 2 holes here. Grab 2 out. Plug in my tool again. Pop those in there. We only need 2. So I'll unplug that because we shouldn't need that again for the moment. Right, so the nose part, PLA. The grille, we printed it in multicolour just to give it a bit of contrast. You don't have to do this by any means, but we just thought it was a nice touch. That's in PLA. The actual servo housing is in PETG, along with the servo arm gears also printed in PETG. So the nose fits in there like that. Is there a right and a left only? Let us try. Yes, there is. So I'm just going to CA glue these into place, let them sit to one side and dry. CA glue, super glue. Yeah, super glue, CA glue, same thing. If you've got super glue and activator spray, that would probably be my go-to, because then you can pop the parts in place like that and spray it and it'll be cured pretty instant. And just wipe off those bits of excess. Get the correct eyes, headlights, eyes, headlights. So I'm just being very, very stingy with the super glue here. I don't want it oozing out everywhere and causing me a calamity. I'll leave that. Next, assemble the servo frame. Use a servo tester to center the servo positions. Now, we don't have the servo tester, so this isn't a necessity. It does say it's optional, but what we can do is basically fit the servos. Once we've powered the unit up, we will be able to then know where the center is, and then we can adjust our little arms accordingly. So here's the said servos. Basically the orientation it's showing me on the drawing. We've got this little point part facing forward. We've got the actual mount there, so they fit on like so. With the servos you get some little screws. So inside there we've got 2 self-tapping screws, and we've got a machine screw which is to screw through the actual middle bit in when we put that on. So 1, 2. We just repeat. It's exactly the same for the opposite side. So again, when putting these in, you're only threading into your printed part, so you don't need to go crazy and strip out your threads. There's a nice little part hole. The screws are going in really nicely. You've got a bit of grab on there. Once you're finished, that is how it should look. So the wire's going that way and those like so. Then in the bottom of these little parts, we've actually got a recess for a servo horn. Fits in there superbly. So showing on the image that sits out at 90 degrees, as close as damn it. And then pop those on top and hope that the little screw they give you is long enough. Now I'm looking at that hole, and that hole is very, very small compared to my screw. So I'll just open it up a little bit just with my screwdriver, like so. Just be careful of your fingers when you do this. You'll want to push the screwdriver right the way through. All you're trying to do is ream out the hole a little bit, and then grab your little screw, get it in place, and then just clear out the threads. Pop that on top of your servo arm, and then just nip it down. Right, so are these now dry enough? Oh, no, not really. You'll have to be very careful. So once you've fitted the arms, it should look something like that. Now what it's asking us to do is, in that orientation, the servo wires will feed down inside there like that. And that presses down into place. Then we get this frame, which locates in the little V at the front. We've got 2 of these little gizmos. I think they're the actual control arms. So they pop into the little track that's in there and engage with those servo gears. And then the console pops on the top like that. I'm not sure what all these bits are screwing in with. So these are the M3, well it says on here 6mm countersunk bolts, but they're not bolts, they're on the packet, they are M310 self-tapping screws with a countersunk head. So they're the only self-tapping screws with that size. And if we turn it over, on the inside we've got 3 more holes. That just secures that frame that we've just fitted to the actual nose cone. Next is the bludgeon weapon. We have a bludgeon, and we have 2 variants of these parts because I'm not sure which one ours will use. I think it's going to possibly be that one because this servo, which comes with this big hefty arm, will fit on this. I think. Don't quote me yet. I could be wrong. I do believe that's another part. And that. And we also want that. So first thing it's saying to do, it's telling me on the drawing to fit a rubber grommet and a brass bushing. Place the brass bushing inside the rubber grommet. So pop in another grommet into the other side. It doesn't tell you that on the drawing. It shows 1 grommet and 1 brass bushing. So the image is a little misleading, but the actual text does say. I think we should probably, even though it doesn't say to it, do that on all of them, because I do have enough parts to do that. So why not fit the servo into the main fin? This is the main fin showing that way. So cable goes down there and it appears to go like that. Fix the servo in place with 4 screws that came with it. So in here I have 4 screws. That's better. We have this part now. It fits over like so, and then it wants us to fix that down to 20 countersunk screws. So these you just cut in, thread into the printed part. There's no heat inserts. So again, just snug them down, don't go mad. Saying to use a servo tester again to center this. Obviously, as we already mentioned, we don't have one. We'll have to wait until it's actually powered on. So it says fit the metal servo horn onto the output shaft of the servo with the arm facing the rear of the racer. Tighten down the clamp screws. So I do believe this is the rear. So pop that on there, and we have 2 little locking screws. The right size arm key for them. It's in there, and one on the opposite side. And then we have this, which will fit on like so. But first, there are some options next in the BigTreeTech kit. There is a carbon fibre rod, which is here, which is pre-drilled for the bludgeon and the bludgeon bracket. Right, so we've got 2 holes this end. So I'll pop that through there. Oh dear me, I don't want to break that. It's very tight. So I now need a Phillips. The bludgeon of doom. Okay, I think we can call that part of this escapade complete. I've got 3 holes in the bottom of there. I believe we're going to have to use those to connect it to the rest. So it hasn't mentioned that so far. So next up it's going on to the rear frame. So for the rear frame, more parts, more heat inserts, more screws, magnets, optional. I have no magnets. But we also need the trusty CA glue again. Let me gather the parts. I don't need that, so I can ditch that. Looks like we have one. We have lots of little bits of that, and we have another one of those. And this part here, those 2 holes require a heat insert. So let me grab my wire, plug in the melty tool. This isn't a melty tool, by the way. It's Modify 3D, available from 1233D. Check out the link in the description. This is the Pro variant. Come on, faster. We have a schedule to keep. I just noticed there's another bit missing. We are at 300 degrees C. Insert the insert. Super. Be careful with that. It's very hot. Right, next up, we went a little bit different again. Printed in PLA. We did this in multicolour. It was actually printed, I do believe, on the Creality K2 combo. Check out the link in the description. Okay, so it says next, sandwich the seat base between the seat frame and screw it down with some M3 12mm screws. Now I'm assuming it wants me to go right through the whole shaboodle. So I'm going to make a judgment call. I might actually go for these M310s, see if there's enough. Oh yeah, they're the badgers. So I'll take that one out and replace it with that. We have a seat ready for a driver. Right. Rear frame. So, rear frame shows the grille, fits in like so. We will grab our super glue very, very carefully, put a little bit of that inside the recess, little by little. We don't want to look. Just grab the frame, pop that in there like that, hold it down with my finger. Little bit of activator spray. We are golden. Now it says that this slides in there. It doesn't say to glue it, so I'm unsure, because it might be an access hatch. I don't want to glue it in place to be snookered and not be able to get to what I need to get to later on, should I need to. Again, these, I am going to glue them. Just make sure they fit first, which they do. They fit very well. They might not even need glue. There we go. So just inside that little hole, I'm putting the glue on this one, because that way it shouldn't ooze out everywhere. Make sure it's seated all the way in. Give it a quick spray and repeat with the other one. You don't need a lot of that. Okay, so rear frame. This is obviously our rear frame. So that's going to fit like so. So now I have holes in there. I find the magnets work very well without bolts to hold the rear panel in place. If you want to use a bolt, there is a countersunk hole, which there is. We shall ignore that fact now. And basically what it's telling us to do through the holes in the bottom, fix the assembly, so the bludgeon assembly to the rear frame assembly with 3 M3 16mm countersunk bolts. Right, we are just about to fit the fan to the front of the machine, which is optional. So for this, I am using M3 15mm button heads. There's only 2 screws into the bottom. Fan is fitted like so. Basically, to pull air through the chassis. I think we could also probably, at this point in time, fit the nose frame over the fan and the main frame secure down with 2 M3 8mm. We have some of them, so I'm not 100% sure how this goes. We shall try. Okay, I think we can do that. So I've got 2 M3 8mm screws. I will show you where these have gone. Basically what I've done, the actual nose cone is hooked over the fan. So the fan does exactly what it says. It pulls air in through the grill and then blows it backwards. And then secure that in place with these 2 holes here. They are screwed into heat inserts we inserted earlier on into the actual nose cone. So I'm just making sure that all the wires we're pulling through into the middle of the actual chassis for when we get to the part where we're going to have to hook everything up. It's a fair weight without even a battery in it yet. Colour accents into the helmet. 2 little accents of colour. We need to place a couple of inserts into our character. Have 2 of them out. Let's plug in the tool. Totally optional. You can use the stock head or you can personalise, which we decided to personalise to a very fitting member of our team. So Sam Flan, if you are watching, we shall proceed to bury heat inserts into the back of Sam's head. Again, I'll plug that. So 2 inserts in the back of his head. Then obviously if you look through the helmet, we've got 2 holes. M3, sorry, 8mm will work absolutely perfectly. Snug him down, and there he is. So we have our rider's head. Yeah, so how we got such an accurate representation of Mr. Flanagan, we used the Creality Raptor scanner, in fact, to 3D scan his head in a previous video that we did. So we'll link to that down in the description. But yep, the results are very, 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 very good. Bludgeon, blosh, bish, bosh. Assembly bolt down to the rear frame using 3 M3 16mm screws. We should have probably recharged the drill, Chris. Okay, so I've just assembled the bludgeon tower to the seat via these 3 holes in the bottom. Next, we want this hefty beast. So bolt the rear frame to the main frame with 4 M312s, if I can open the bag. So there we have 4 of those. So 2 of them are into heat inserts, and the other 2 are going into fresh air. That's 1, that is 2. Now I can only guess the other 2 just screw through the top down, which they do, but I'm not overly impressed by that. I'm going to put some heat inserts in the top holes. I mean, ultimately, this isn't a battle tank by any means. I believe that we still want it quite robust. So I'll just pop them screws back out, remove this, and then I've got 2 holes on the top that I will just pop in some heat inserts. Peace of mind. Doodly doodly do. Beautiful, beautiful, beautiful. Right, here we go again. Wire through the hole. Sit that in place. That's better. And now I've actually something to fasten to. And there we have it. A racer with no driver. So far, as you can see, progress has been made. We have a near complete Death Racer. So please don't forget to like, subscribe and share. And if you've got any questions regarding this build or any of the bits and pieces that we've come across during assembling this, please give us a shout. We'll do our utmost to help you and get back to you as quickly as we possibly can. Hope you've enjoyed the video. I will catch you on the next one. Bye-bye for now.
As always, we aim to have the most competitive 3D printer prices on the market. If you see any of our printers being sold by a mainstream retailer for less, please drop us an email using the link in the description and we'll do our very best to beat their price. Also, if you're watching from outside the UK, check the description for links to our European 123 3D sister stores.